Vibration analysis goes beyond simple measurements like acceleration and velocity. It uncovers the energy, forces, and structural integrity that determine machine performance. Vibration measurement is more profound than it seems. It involves understanding the energy, hidden ratios, and reliability assessments that affect machine operations. Different vibration parameters reveal specific energy types. Displacement, velocity, and acceleration each indicate unique energy impacts on machinery. Dynamic stiffness is the hidden equation behind machines. It involves force, stiffness, mass, damping, and frequency, each playing a crucial role in machine behavior. A vibration spectrum reveals more than just vibration. It shows force generation, system response, resonance proximity, and energy flow, telling a story of resistance. Most vibration analysis misses deeper physical questions. It's crucial to distinguish between increased force or reduced stiffness to diagnose issues accurately. Dynamic stiffness offers a unifying framework for understanding root dynamics, connecting rotor dynamics, structural resonance, and more. Dynamic stiffness shifts the focus in vibration analysis from frequency to changes in force or stiffness, helping identify fault modes effectively. Key takeaways include understanding energy types, cause-based diagnosis, and the unifying role of dynamic stiffness in fault modes. In Part 2, we'll explore distinguishing force and stiffness problems in practice, using dynamic stiffness for real-world fault mode identification.